What's going on, guys? It's Cooper Codes, and in this video we're going to create an Apollo server backend that's going to allow us to send HTTP only cookies to an Apollo client frontend. We're then going to use Apollo client to manage cookie requests, such as sending the user's cookies to the backend or asking for new cookies. We're also going to show how Apollo server can read these HTTP only cookies from the user. So this is the actual project that we're going to create. As you'll see here, we set this cookie here. Its name is token. It has a value of token_value. This cookie is an HTTP only cookie. If we go over to our console and we try to access the cookies locally in JavaScript by saying document.cookie, you'll see that the only cookie showing up is some state cookie from React. You cannot access this HTTP only cookie using JavaScript, which makes it super secure. You'll also see that in our local storage, we have nothing. And in our SessionStorage, we also have nothing. If we were to store data locally a different way, there's a possibility that a hacker would be able to access the session or local storage and then get possibly sensitive information. By using HTTP only cookies, only the server can read that data and change that data. It's impossible for the user to edit any of the HTTP only cookie data. All right, let's get started by looking at the code. We can get started by going to an empty folder and creating our npm project by saying npm init --yes. This is going to give us an empty package.json, which we can load some npm packages into. For this project, we're going to need to npm install apollo-server-express. We're also going to install cores, and that's it. All right, so now we can get started by building out the Apollo server backend. We're going to start by creating a server.js file to hold all the Apollo server code. Let's start by including all the different packages we're going to need for our server. First, we're going to need cores. Cores is going to ensure that our requests can only come from our React frontend. We're also going to include Express. Express allows us to quickly create a web server we can run Apollo server on. We're then also going to include the Apollo server packages we need. So we're going to say const Apollo server and also GQL, which allows us to write GraphQL language. And that's going to be coming from the package Apollo server express. Oh, I forgot about this one. So we're also going to want to npm install cookie. This is going to help us process some of the cookie headers later. So at the top here, we can say const cookie equals require cookie. So those are all the packages we're going to need for creating our backend. I'm going to store the entirety of our backend code in an anonymous asynchronous function. It's important that we create an asynchronous function because we're going to be using the await statement when it comes to starting our Apollo server and applying Apollo server middleware. So I'll get into that in a second. And it's called anonymous because this function isn't even going to have a name. We can just write async function, the parameters of the function, and then the code that's going to go inside of it. These outside brackets are going to wrap the entire function. And so if we want to call this asynchronous function, for example, to start our server, we can do it just like a regular function call where we have these two brackets at the end. So you can think of it like this. This is the actual function code, and right here is calling the function. So first I'm going to start by defining our Express app. So this is the actual web server that Apollo server runs on top of. So I can say const app is equal to Express. And so that's super simple, but it defines an entire server for us, which is why Express is helpful. I'm also going to include some cores options for extra security. We can store these in a variable and just call it cores options is equal to, and we want to ensure that our requests to the web server are coming from the origin of our frontend. In this tutorial, I'm going to have the React frontend sit on localhost 3000. And I also want cookies to be coming back and forth. So we have to say credentials is true. This allows the cookies to be sent from the frontend to the backend. And so we can say app.use to enable this middleware, then going to call the cores function up here that we included, and then we're going to pass in these cores options. So now cores is fully enabled. All right, so before our application, I'm going to define the type definitions and the resolvers of our Apollo server. For this video, we're going to make an incredibly simple backend because the main focus is on the actual transferring of the cookies and not creating complicated backend code. So I can define some type defs by saying const type defs is equal to GQL, which means we're going to start coding in the graph querying language now. I'm just going to introduce one type, a type of query. And this query is just going to constantly set the cookie and it's going to return a string, which will just say, like hello world or something along those lines. Whenever this query gets hit, we're going to be setting the cookie and pretty much giving the user a cookie, for example. So let's code out the logic behind set cookie by making a const resolvers. Resolvers allow us to define the functionality of a certain query, like setCookie, for example. We're going to say query first because we want to define one of the queries, and the query we want to define is then going to be setCookie, which we're going to set equal to a function. We're going to ignore the first parameter because it's the parent option in Apollo server resolvers. We don't need that. And we're also going to ignore the second parameter with 2 underscores. This is because that's the actual parameters you might want to pass into your resolver. For our case, we're going to have none. In here is going to be the context object, which is something that we can define when we start our Apollo server. I'm going to make sure that the response and request are both included in our context. So this is something that we have to define later, which I will get into. We can make an arrow function to say we want the logic of this resolver to be defined as this. I'm just going to make the return statement first because it's super simple. I'm just going to return a string saying cookie set. In our response, we can actually give the user a cookie by saying res.cookie. We can then define what we want the cookie to look like. We can make the name of the cookie, for example, token, and then the value of the cookie, token_value. We're then going to have a bunch of different options we can pass into the cookie here. If you're curious on any extra options outside of just this tutorial, just look up res.cookie, you'll find all the documentation. So let's make our options object here. I'm going to use the expires property to set a date for, let's say, new date, date.now, and let's just add something like 900,000 to it. That's going to ensure that it's not going to expire right away, and it's going to expire in a while. We also want to ensure that we have the HttpOnly option on there. This means that the cookie is going to be only accessible by HTTP, aka only accessible by our server. We're also going to set secure equal to true, so on production environments, it's only transferable over HTTPS. That way a hacker can't even try and intercept it. Even if they were to intercept the code, it would be under HTTPS, and that would be encrypted, so they'd have no way to even see the data. I'm also going to set the same site property equal to true. For our case, this means that both the backend and the front end are going to be based off of localhost. So if you were to get a, request from some random domain, you wouldn't even entertain that request. You just deny it right away. Because the front end's going to be on localhost 3000 and the backend's going to be on localhost 4000 or something. We'll determine that later. And so this is actually going to fully send a cookie to our user. We don't even have to say any weird like res send cookie or anything like that. This by itself is going to pretty much give our user the cookie, which is pretty cool. So if a user makes a request and the request has headers, we can check that by asking if request exists and request.headers exists as well. From here, we know that we have some cookies we might be able to look at. So we can say const cookies is equal to cookie.parse rec.headers.cookie. If you look up request.headers, you'll see where this .cookie property comes from. It's pretty much going to give us a list of all the values of token and token value, kind of like that. The interesting thing here is because the request is being sent over HTTP, we're going to be able to see this cookie. That's why this is so secure, is right here in the code is the only time where we can read that cookie. If you're on the client side, it's impossible to read the cookie through JavaScript. And so we can also console.log cookies here. All right, so that's the only query we're going to use in this video is just this very simple set cookie. It's going to set it to the same value every single time. We can obviously restart our server and change the values here, but this is just a very simple tutorial showing the full process of using HTTP only cookies. All right, so now that we defined our typedefs on our resolvers, we can make our Apollo server based off of these. So let's go down to the bottom here and say const server is equal to new. Then we're going to use the constructor for Apollo server. And this is a very common pattern in JavaScript is to give config options or like config in an object. We're going to tell Apollo server all the different types of things it needs to pretty much build the server for us. It needs typedefs, like what are the type definitions of my server, then also resolvers. For example, how do I resolve the set cookie query? If it doesn't have this code, it doesn't know what to do and it'll get confused. And then very important, we're going to set the context of our Apollo server. Context allows us to grab two very important things, the request and the result. This is how we're able to access request and result up here is every single resolver inside of your Apollo server has access to the context. And so if we want request and result to be a part of that context they can access, we can do this. We can pretty much say, handle the data by making an arrow function here. Okay, we're going to define the code of the arrow function, and we're going to make it just return request and result by default. This means that in our context, we can access request and result. If you look up Apollo server context online, there are also other good examples of possibly doing some logic inside of this context. Our logic is very simple. It's just saying get the request and the results from the request to the server and then pass it into the context. It's very simple. All right, and that's our fully defined Apollo server, which is great. So now we can use an await statement. It's very important to understand we're able to use await in this case because this is an asynchronous function. Very important to understand that. And so we're going to say server.start. And so afterwards, we can just do a little console.log saying server started, just so we can kind of see where we are. And then we can also apply middleware to the server. Our middleware is pretty much going to allow us to have a different path to our application. So we're going to say apply middleware to the app, which is going to be that Express server. And we want a GraphQL path for our code to be able to interact with. And we're going to make cores equal to false. I'm going to make another console log saying middleware applied. And now we can finally allow our Express application to listen to a certain port for requests. For example, we're going to app.listen to port 4000 is where our backend is going to be located. And then we can define what we want to do when this is done. And for our case, I'm just going to do something very simple. I'm going to say console.log server is ready at port. Or I'm going to say at, let's just do the full link, local HTTP localhost 4000. And then we can actually get something from the server here because it's already started. We can get to the server GraphQL path. And with this syntax, you want to make sure you don't have a semicolon at the end or else it's going to break. There we go. Oh, guys, I'm going to make this a super huge emphasis. You want to make sure that this path is /GraphQL. I'm going to make sure to keep it here for a second. Make sure this path right here is /GraphQL. My bad. I missed that for a second there. Okay, so to start our application, I'm going to go over to our package.json. And I'm going to go to these scripts. These scripts allow us to say things like npm start, for example. So I can put a comma at the end of test here. I can make a start command. And whenever we start the application, I want to say node server.js. So use node to run the server.javascript file. When server.js gets ran, it's going to call this asynchronous function right here. And then it's pretty much going to build our entire server. That's kind of the thought process you guys should think about this. All right, let's try out npm start to see if our backend's up and running. Amazing. So the server started, our middleware got applied, and it's ready at localhost 4000 /GraphQL. So just to clear up any confusion regarding this, if you guys are at this point of the tutorial and you're trying to go into the sandbox and you're trying to see if you can query your server right now, you actually cannot. But this is actually a good thing because imagine you were a hacker trying to query your server from a different, domain. In our Visual Studio Code over here, we've actually forced the cores to only allow origins of a localhost 3000. To further your understanding, I'm going to show you guys something interesting. So this isn't part of the tutorial, like skip passes if you want, but instead of that origin of localhost 3000, we can go in here and get this studio.apollo.graphql.com origin. We can go to our origin here in the cores and say, okay, I only want to accept requests from this origin, and make sure there's no slash on the end there. Google actually added that by itself, I think. And so instead, we're going to say, hey, only allow requests from this origin. So if we restart our server, we're actually going to be able to access it from the Apollo Server Studio, which is pretty interesting. So as you guys can now see, the schema is now on. We are green, we have no errors, and we're able to make queries like we'd expect. I'm not going to add any queries in here quite yet, but this is just to show you guys how that core stuff is working. It's pretty much saying only allow requests from our front end. That way, if a hacker tries to make any requests, boom, instantly denied. So let's go back here. I'm going to bring this back to the localhost 3000. Make sure you bring that back. And you guys didn't have to code that, by the way, just more of an example. Now we can get started when it comes to developing our front end of our application, so the actual React part. So in our terminal, I'm going to make a React app. I'm going to say npx create-react-app. I'm just going to call it front end, all lowercase. This is going to build a React project right next to our Apollo server, so they're kind of side by side. All right, so now I'm going to cd into our front end folder, so we're over at the React part. As you guys will see, we have our full React front end here with app.js and package.json, all that stuff. And so making sure that you're in the front end directory, we're going to npm install the @apollo/client. This is going to allow us to interact with our Apollo server and do the full Apollo client setup. So we're going to go to the source folder and go under index.js. This is kind of where your React application gets started up, and it's where you'll see a lot of kind of setup related things, especially when it comes to Apollo server. And so we're going to import everything we need to kind of set up our application to use Apollo Client. So I'm going to import, I'm going to use some curly braces, which means we're going to import multiple things from a package. And I'll do the package first here, where I'll say from @Apollo/client. We're going to want to import Apollo Client, in-memory cache, Apollo provider, and also create HTTP link. And I'll explain these as we use them. First thing we're going to want to do is we're going to want to make an HTTP link to that GraphQL route we made before. So I'm just going to say const link is equal to create HTTP link. It's a constructor and it requires a couple of options as to how you want to define your link. We want the actual address of the link, so we're going to say URI, to be equal to HTTP localhost 4000/GraphQL. Oh, make sure you spell that right. And we want credentials include. I also discussed this in the backend, I think, one time, but credentials includes important because it allows us to send cookies back and forth. So very important there. And so now we can create our full Apollo client, which our entire application is going to use by saying const client is equal to new Apollo client. So a constructor here. We want the cache of the client to just be the new in-memory cache. That's like the default almost option for Apollo client. And then we want the link of the client to be equal to our link const above. This means that whenever we make requests with our Apollo client, it's going to use this link here. The last thing we need to do is use our Apollo provider. It's in the name. Apollo provider allows us to provide Apollo functionality to our entire React app. And so we can define it by saying Apollo provider, and then the client we want to provide to our application. So we can say client property is equal to this client const we made right here. You want to ensure that you wrap your app around like this. You can imagine it's like a Christmas present or something. Apollo providers on the outside is kind of like wrapping to the paper, and your entire application for React is on the inside. So it's just kind of like a layer, like a present that goes over your entire application. All right, so we can go over to app.js. This is currently showing what our application is going to look like. I'm going to get rid of everything except the div and the header just so we keep that styling so it looks okay. Obviously, this isn't like a front-end styling tutorial. And I'm going to create a React component, a functional component that allows us to load in the cookie right away. So go to your source folder, and I'm just going to make something called loadCookie.js. This is a very simple component, so if you're new to Apollo Client, it should be relatively easy to follow and kind of like a nice first example. When I was first working with Apollo, there was a bunch of random things going on that were kind of hard to understand. So hopefully this example is easier to understand. We can start by importing two different things. We want to use GQL to actually use graph querying language to make a query, which I will show you guys. Don't worry if that sounds complicated. And we also want the use query hook. This allows us to make queries to our Apollo client. And these are going to be coming from @Apollo/client. So when you work with Apollo client, it's very common that you want to define your queries. Kind of like if you were using like an SQL or MongoDB, you want to define how you ask for data. So we always do that by saying const and then the name of the query. I'm just going to call this set_cookie, and it's generally in all caps, is equal to GQL. This little GQL tag and then these backticks right here mean that we are going to start talking in GraphQL language, not JavaScript anymore. So we can say query. This is just to say that we want to use a query, and the one we want to use is setCookie. We don't have to do anything beyond this because setCookie has no parameters, and we're not even getting any data from it besides the cookie itself. So that's why this query is so simple. We are done here. And so now we can get started by creating the actual functional component that's going to use this query. So I can say function load cookie. It's going to take in no properties because it's kind of just a standalone on its own thing. And then we are going to use the use query hook. So I'm going to say I want to use the query of set_cookie, which we defined above. When you use the use query hook, it's going to return a couple things. So we can get those things by saying const, then an object is equal to, and it's going to give us a couple of properties that are defined in documentation. For this case, I want the loading, I want the error, and I want the data. And these are all handled by the use query functionality. All you have to know is that if one of these changes, our component's going to refresh. And so we can make logic like this. If the component is loading, return null. So if it's loading, we don't want to show anything. If there is an error, we want to return the error to our front end. So I'm going to say error, and then I use some $ syntax here, $ error like this. And I use backticks there to use that $ syntax for the variable. And I'm just going to do a little console.log data. I might as well here. If you get past these two if statements, that generally means that your data has some type of object which we can look at in the console. Then I'm just going to return the actual component. So the return statement is going to be, what do we actually want the component to show? I'm just going to make a little header thing that's very obvious and large. And it's going to say, we have sent the request. With this syntax, the use query gets ran right away. Right when it's defined, boom, use query set cookie, it's going to run right away and get you that data as fast as possible. And so we've sent the request and received. And if we want the data that's the set cookie query returned, we can say data.setCookie. This is just going to be that string that we're getting from the backend. And I'm also going to give us a little note that's saying check to see if the cookie is there. These cookies are going to be sitting in our browser instead of the actual front end part, so I got to go look. And with HTTP only, we actually can't even access the cookie from JavaScript if we wanted to. All right, so now that we have this full functional component, we can export default load cookie. This means that if we ask for the component from a different file, then it's going to give us load cookie. We can go over to app.js and import load cookie. And so we can use our load cookie component like this. It has no properties or anything like that. And so we're good to go. So before starting our application, I'm going to do something called a split terminal in VS Code. This is going to allow us to look at the front end on the left and the back end on the right. As you'll see, we're in the back end over on the right. We're not on the front end path right here. And so if I npm start over in the back end, it's going to launch our server and start hosting it locally like you'd expect. We need the server to be running in the background because we're making requests to that server, right? So both of them have to run at the same time. Split terminal is just a feature of VS Code. You can also just use two different terminals. It's the exact same thing, but just so you guys know what's going on is why I explained that. And so over on the front end, we can similarly say npm start. And sorry, it's kind of getting cut off, but this is all in one line. Npm start, simple command. All right, so it's looking good. We actually received cookie set, which is that string we returned in our backend. So if we inspect element, and in Chrome, you're going to want to run over to application. Oh shoot, look at this. We now see token underscore value has been set. The interesting thing is this token is going to stay even when we refresh our page. So do you see this G underscore state here? That's the tokens that the server currently sees. And so if we want to make another request to the server, we can create a pretty much button to constantly request data to the server. If we refresh our page, it's then going to show the server recognizing that our token exists. And so that's pretty cool. Not only does it mean that the token stays after refreshes, it means that the server is able to look at the value of our token. You could imagine if that's an access token, a refresh token, whatever you use for your case, you're now able to get the actual values from the user's cookies. So let's go and make a button component to make these requests manually, so we can kind of see what the server is seeing from the user. So let's go back to our React, and I'm going to make another component. I'm just going to call it cookiesButton.js. And I'm actually going to go over to load cookie here. I'm going to Control A, so copy all the code from load cookie and bring it over to cookiesButton. I'm going to change this to cookiesButton, so the name of the component. Make sure you change the export default as well. And so it's still going to use the set cookie query, and it's still going to use the Apollo client up here, so we don't even need to change those. This use query is the same, except we're going to get one more thing from the use query hook. We're going to get the refetch. Refetch allows us to use this query again. You guys remember how I was talking about how this query instantly gets ran? Well, we can run it again by using the refetch, which is a very simple function, which we call by just saying refetch with some, function call at the end. We can handle loading and error the same way, so we don't even need to change these, except we need to change this return statement into a button. Luckily, it's going to be relatively simple. We're going to make a button like this. I'm just going to say send request to server. So whenever we click on it, we'll send a request. Then I'm going to make an onClick property. So when we click the button, we want to call a function. And for this one, we're just going to call refetch like this. And so if I go and terminate this React and I'll restart it, just to make sure. All right, so that is all we need to make this cookies button component. We can go back to app.js and then import the button. So import cookies button from /cookies button, and we can include the component here. So make sure to refresh your React application. All right, so now we have a button. If we press send request to server, you'll see in the bottom right here, we're going to keep on getting that token value over and over again. And so You go under application again to look at our local tokens. A very interesting thing here is you can actually delete this token as a user. So I'm going to delete it like this. And then I'm going to send a request to a server. You'll see right now, the server doesn't see the token because we didn't have it in that request to the server. There was no token, but during that request, the actual server set the token. And so now that we have the token set, if we send another request, now it's going to recognize that token underscore value. And so this is super powerful and interesting technologies, especially how we set it up with cores. It's going to help a lot of different issues people generally have when it comes to web security. If there's any closing statement I have to this video, because honestly, this is kind of the video, guys. Hopefully it was, informative, helpful, and helps you set up a Apollo server and Apollo client, of course. But if there's any final statement I have to this, it's that there is no perfect solution when it comes to, JSON web tokens, when it comes to managing authentication. But I do believe HTTP only cookies are a really interesting thing to look at if you have a small amount of data, such as an API token, that you want to be secure and that you want hackers to not have access to. I will mention that one of the main flaws of using these cookies locally is that a situation like this can happen. This is a great picture. So pretty much the victim here is going to get our cookies like we have defined here. Imagine token underscore value. If the victim then makes a request with these current values inside of their cookies to a hacker, the hacker's backend is then going to be able to see the tokens because at the end of the day, it's still HTTP, right? But the thing that's interesting is with how we have these tokens currently set up, we're only allowed to make requests to localhost in our example. You can imagine if we were an actual domain, like, I'll just do a comment randomly here, like facebook.com, we're only going to be able to use the same site, for example. So we're only going to be able to use like facebook.com/API/users. And so that's another reason why I really believe HTTP only, cookies are a super powerful security solution. But I still have to make you guys aware that this is a common attack that happens regarding local cookies and using them in your applications. So just so you guys are aware of this, feel free to do your own research into cross-site request forgery, of course. All right, well, thanks so much for watching, guys. Hopefully you found this informative and have a good one.